Hi guys. Today I'm going to be presenting about the Carnot's theorem and some of its extensions. So let's get started with the theorem. Let O be the circumcircle of triangle ABC. L, M, and N are the midpoints of BC, CA, and AB. Then OL plus OM plus ON is equal to R plus R, where large R is the radius of the circumcircle and R is the radius of the incircle. Well, this is a pretty handy equation for, you could always use them in like contests or anything, so this might be a good equation to memorize. Well, you should understand it first, right? So let's go on with the proof. Okay, the proof is actually pretty simple. Well, I drew the triangle ABC right here, right? If we just have to note that OM is OM is perpendicular to AC, right? Because M is the midpoint of AC. Well, so if we look at all these perpendicular conditions, then we can see that there are three cyclic quadrilaterals that we could see, right? We could see that AMOM, NOLB, and OMCL are concyclic. So then, because they are concyclic, we know that we can use Ptolemy's theorem on all three of these cyclic quadrilaterals. Let's do that. So by Ptolemy on triangle ANOM, NOLB, OMCL. Okay, the first one, ANOM. Let's just first let me label the length of AB as C, and the length of AC as B, and the length of BC as A. Well, this is pretty standard configuration, right? Now let's use this. Let's use Ptolemy's theorem. ANOM, C over 2 times OM plus B over 2 times ON is equal to AO times NM, right? But we have to note that NM is half of length of BC. So NM is just A over 2. A over 2, right? And AO is just the radius of the circumcircle, right? So we could just write R. Let me just do the same for the rest. So let's just add all of these up, right? Let's go ahead and add all of these up. Well, if we add all of these up, let's first group them up by ON, OL, and OM, right? So first of all, for OL, we could see that B plus C over 2 times OL plus A plus C over 2 times OM plus A plus B over 2 times ON is equal to A plus B plus C over 2 times R. That was pretty neat, right? Now, let's complete the rest of this equation. Well, it kind of seems like we want to add some terms up here to both sides, and then everything else will cancel, like A plus B plus C over 2 will cancel on everything, right? So let's try to develop an equation and try to think that this is true, and then let's prove it. Okay. So note that A over 2 times OL plus B over 2 times OM plus C over 2 times ON is equal to the area of ABC. So this is the symbol for the area of ABC. So how is this true? Well, this is actually pretty simple. If you look at this, what is a over 2 times OL? Well, a over 2 times OL is a times OL times 1/2, right? So that is indicating the area of triangle OBC, right? So this is actually area of triangle OBC, and this one is indicating area of triangle OAC, and this one is indicating the area of triangle OAB. So that's why this sums up to the area of ABC, right? But we know how to we know what the area of ABC can be represented as in terms of small r. ABC is equal to S times R, right? Which is also equal to A plus B plus C over 2 times R, small r, right? So from here, we can see that if we add, let's call this equation 1, and let's call this equation 2. If we add 1 and 2, right, then we're going to get the desired equation. So let me just do that. We get that A plus B plus C over 2 times OL plus A plus B plus C over 2 times OM plus A plus B plus C over 2 times ON is equal to A plus B plus C over 2 times R. So this is done. So now that I have proved this equation, let's go on with some extensions and some other cases of Carnot's theorem. Because first of all, I only gave the proof for when it was wait, give me a sec. I kind of mistaken this, but I have to include that ABC is actually an acute triangle. So let me acute triangle. So I'm sorry, but this equation only holds for the case when ABC is an acute triangle.